So we are going to multiply the polynomial using the area model. And so I see that I have one polynomial, specifically actually a monomial, because it only has one term in it, being multiplied by another polynomial, which more specifically is actually a monomial, because it only has one term in it as well. So I have a one term being multiplied by another one term. So when I go to use my area model, and I'm going to do it rather large because there's a lot of writing that I actually want to write on the inside, because this is our first lesson, and so we need to see some more closer details. So my first term is going to go right here. My second term is going to go right here. So this side length is represented by the first parenthesis. The second side length is represented by the second parenthesis. So since there's only one term in here, this entire length is equivalent to 5x squared. And since there's only one term here, this entire length is represented by 4x to the third. So now we are just trying to find the area like you would in geometry class. So you would have this 5 being multiplied to the 4, and you know that x's get multiplied to other x's. So we are multiplying the 5x to the fourth by the 5x to the second by the 4x to the third. And so you know when we multiply, the numbers get multiplied together. So 5 times 4 is 20. And when we multiply x's together, they have the same base. If you remember, that meant that you added your exponents together. Because what you're thinking about, so if you need a quick refresher, x squared times x to the third is the same thing as saying that you had 2 x's and you were multiplying it by 3 more x's. So this is the same as this. So x squared, here's your x squared. X to the third was right here. Well, how many x's did we have multiply all together? 1, 2, 3, 4, 5. I ended up having 5 x's multiplied together, which is the same thing as 2 plus 3. So we're going to add the exponents together. So the area is 20x to the fifth. So when you were multiplying this, you're telling me that the quantity of 5x squared multiplied by the quantity of 4x to the third is 20x to the fifth, and this is our final answer. For our next practice problem, we have a single monomial, again, being multiplied by another single monomial, and we're asked to solve it using the area model. So here is my rectangle representing my area model. The first parenthesis is supposed to represent an entire side. Since my first parenthesis only has one term in it, that entire side is represented by that one term. The second parenthesis represents the second side length, and since the second parenthesis only has one term, that side also has only one term. So the area of this is us multiplying it all together. So all of this has to be multiplied with all of this. And we know that when you do that, the numbers actually get multiplied together. The x's get multiplied together. And the y's get multiplied together. So the -3 and the 4 go together. The x to the third and the x get multiplied together. And the y squared times the y to the fifth get multiplied together. So when we're trying to do this, -3 times 4 is a -12. When you multiply same base x's, we're supposed to add their exponents. He has a secret exponent of actually a 1 that we are lazy and we just don't write. So this is x to the, supposed to add them. So here's me showing you adding them so we don't forget. And same base y's get multiplied together. And since they have the same bases, we're supposed to add their exponents. So the area of this entire rectangle is a -12, x to the fourth, y to the seventh. So when you are multiplying -3x to the third, y squared, by the other quantity of 4xy to the fifth, you get the total answer of -12, x to the fourth, y to the seventh. And that's your final answer. Our next example problem, this parenthesis is supposed to represent one side, and this parenthesis is supposed to represent the other, because we are told to do the area model. And since there's only one term on this side, there's my one term. Since there's only one term on that side, here's my one term. So we're supposed to multiply these together to figure out the area of this. So it's supposed to be 6 times 3, and the x's actually get multiplied. So you know that 6 times 3 is 18. When we multiply same bases together, they're supposed to have their exponents be added. So this is 18x to the fifth. So when you are multiplying the quantity of 3x to the third by the quantity of 6x squared, our total answer is the area of this rectangle, which is 18x to the fifth. Our last example problem for the day, we're supposed to multiply this polynomial, multiply the polynomials, using the area model. So here is a polynomial. Since it's only one term, and that meant that that area model side only gets one term. So this is 1/2 a to the third b. And since this polynomial only has one term, that meant this side also only has one term. So there's my one term. We're supposed to multiply the two sides together to figure out the area of this rectangle. So this does have a number in front of it. It's a secret ninja 1. So we actually have 1 times this 1/2. The a's need to be multiplied together, and the c's need to get multiplied together. Go alphabetical order. So let's multiply the b's together, and let's multiply the c's together. So 1 times 1/2 is a 1/2. When you are multiplying exponents together, remember if they're the same base, you're supposed to add their exponents. There is no other b to be multiplied with, so b is by himself. There's no other c to multiply with, so c is by himself. So your final answer is 1/2 a to the fifth b c squared. So when you are multiplying the quantity of 1/2 a to the third b by the quantity of a squared c squared, the entire answer for the area of this inside rectangle is 1/2 a to the fifth b c squared.